all, we are going to look into introduction of system of linear equations. So, what is system of linear equation? A system of linear equation is a collection of two or more equations involving the same set of variables. So here, we have the general form where aij is the coefficient and xi is the variables, meanwhile bi is the constant. So, Gauss elimination is a method of solving linear equation Ax equals to b by bringing the augmented matrix into echelon form. So, to solve this linear equation, we must use back substitution. So, this method is a method of solving linear system Ax equals to b by bringing augmented matrix to reduced echelon matrix. And to solve this problem, we need to use back substitution, same as Gauss elimination. The next method is inverse matrix method. The first one, you need to check whether the determinant of A is not equals to 0. The second step is find A inverse. So you can choose two methods. The first one is ERO and the second one is adjoint method. However, for adjoint method, you need to use the following formula. And the last step, you can find the x by multiply A inverse with the b. So, for the last method is called as Cramer's method. The first step is you need to check whether determinant of A is not equals to 0. And at the second step, replace each column of A with B, and then you can calculate the determinant of A1, A2, and A3. And the last step, you can calculate x1, x2, and x3. You can refer to the following example for further understanding. Next, we are going to look into types of our solution. First of all, we have finite solution, infinite solution, and the last one, we have no solution. So now, I have done with the introduction part. Next, we will look into the examples and also calculation. Stay tuned.
There are three blocks in TSO, namely L07, L20, and L13. All students in these three blocks need to take the bus to the Faculty of Chemical and Energy Engineering Faculty to be informed that there are three buses at each time slot and each bus has 46. During 7 AM to 8 AM, there are 1/3 of L20 students, 6/13 of L07 students, and 3/14 of L30 students taking the bus. During 1 PM to 2 PM, there are 5/9 of L20 students, 34/39 of L07 students, and 31/42 of L13 students who do not taking the bus due to the industry visits. At 3 PM to 4 PM, there are 2/9 of L20 students, 60/39 of L07 students, and 11/21 of L13 students taking the bus.
Based on the problem statement previously, we can obtain three linear equations for three time slots, where x is the number of students living in L12, while y and z are the number of students living in L07 and L13 respectively. There are four methods to solve linear equations using matrix. First method is Gauss elimination method. Before starting, we need to write the three linear equations into an augmented matrix. Then, perform elementary row operations, EROs, to change this matrix into row echelon form. Once we have row echelon form, we can use back substitution to solve for the variables. And now we get x is 198, y is 84, and z is 78. The second method is Gauss-Jordan elimination. This method is similar to Gauss elimination, but instead of stopping at row echelon form, we need to continue applying ERO until the matrix becomes reduced row echelon form. After the augmented matrix is in reduced row echelon form, the solutions for the variables x, y, and z can be directly obtained from the matrix. The third method is inverse matrix. Let A is the coefficient matrix and B is the constant matrix. And we write the linear equations in the form of Ax equals to B. Hence, x is the value of inverse A multiplied by B. But before finding inverse matrix, we need to find the determinant of coefficient matrix and make sure it is not equals to 0, which means this coefficient matrix has its own inverse. Inverse matrix can be found using adjoint method or ERO. By using adjoint method, we need to find cofactor of each row and each column to get a cofactor matrix. Then, transpose of cofactor matrix will give us adjoint of matrix A. After that, divide it by determinant of A will give us inverse A. By using ERO, we need to apply ERO until the augmented matrix is in reduced row echelon form, and we can get inverse A at the right hand side of the augmented matrix. After finding inverse A, multiply inverse A by matrix B will give us the value of variables x, y, and z. The last method is Cramer's rule. First, let's call the coefficient matrix is matrix A. Then, we need to calculate the determinant of matrix A and make sure it is not equal to 0. To find the value of one variable, let's say x, replace the x column in A with the constants from the linear equations to create a new matrix called A1. Then, calculate the determinant of A1. After that, take the value of determinant of A1 and divide it by determinant of A. Similarly, to find y and z, replace their respective column with the constant to form A2 and A3 and solve using the same formula. Hence, the value of x, y, and z are obtained separately. Based on the calculations done previously, we know that the number of students living in L12 is 198, while the number of students living in L07 and L13 are 84 and 78 respectively.
To summarize, these four methods contain different advantages and limitations respectively. For Gauss elimination method, it is simple to apply and efficient for smaller systems. However, it can computationally intensive for larger matrix. Meanwhile, Gauss-Jordan elimination method solves directly from the matrix. However, it consists of more row operation compared to Gauss elimination, making it less efficient for large systems. Next, inverse matrix method is useful for theoretical analysis and when A is reusable for multiple B matrices. However, it involves computationally expensive inversion, which only applicable if A is invertible. Lastly, Cramer's rule is straightforward for small system. However, it is inefficient for large system and not applicable if determinant A equals to 0. After solving the matrix problem using several methods shown previously, the easiest way among these methods is the Gauss elimination method. This is because the working step in this method is shorter than the other, which means the chance of making mistakes will be minimized. The working steps of the Gauss-Jordan elimination method and inverse matrix method are longer than the Gauss elimination method. The elementary row operations still need to be applied after obtaining the row echelon method until a reduced range echelon matrix is obtained. Additionally, extra steps are required for the inverse matrix method as multiplication is needed between the inverse matrix and the n+1 matrix to solve the matrix problem. Lastly, one disadvantage of using Cramer's rule is that it involves multiple steps, such as calculating and determinant of the coefficient matrix A and calculating another determinant of matrix A by substituting individual column of A with the constants from the equation to solve for each variable. These separate steps can increase the likelihood of errors, potentially leading to incorrect results. The system of linear equation is crucial for solving the problem statement because it provides a structured mathematical framework to determine the number of students in L12, L07, and L13. In conclusion, this system bridges the gap between the problem's real-world complexity and the mathematical solution. It simplifies the task of determining the number of students in each block by ensuring that all the constraints and relationships are met simultaneously.